So good day, everyone. So I'm here to continue the current electricity. So in my previous video on current electricity, I stopped at what electromotive force and potential difference. So the next aspect of today is Ohm's law. Ohm's law. So the Ohm's law is is one of the electricity law which show the relationship between potential difference and current, or potential difference, current, and what, and a resistance of metallic conductor. And the Ohm's law simply states that what, the current that passes through a metallic conductor is directly proportional to the current, is directly proportional to the potential what, difference. States that states that the current produced that passes through a metallic conductor is directly proportional to potential difference. The root is what? PD, potential difference, or let me use what, which is V, provided temperature and other physical quantity remain constant. Other words, physical quantity remain constant. That is Ohm's what? The Ohm's law. Mathematically, the Ohm's law establishes that the voltage is proportional to the what? To the current. That is, when the voltage potential difference of the what of the circuit is increased, the current is also what? Increased. So when the current is increased, the PD is also what? Increased. Remove the proportional symbol, we have V equal to the what? IR. So this is the what? Ohm's law state what? Statement. So let's me introduce a simple calculation here. Example to determine the current flowing in a metallic conductor between 2 points. 2 points of resistance resistance 20 ohms. If the potential difference between these points is 60 volts. So look at this question. You are asked to find the current and the resistance, 20 ohms, and the volt is what is given. So our resistance is what is this? The voltage given is this. We are asked to find the what? The what? The current. So we can say what? The resistance given is what? Is 20, where voltage given is what? 60. But current I is on what? Unknown. What is Ohm's law? V equal to the what? I R. So our current will be what? V over what? Over R. What is V? 60. Then R is what? Is 20. We have what? 3 ampere. So that is the simple arithmetics of what? Of Ohm's law. The next thing is what? We have what we call ohmic conductor and non-ohmic conductor. Or what? Ohmic conductor. See, conductor can be grouped into two. We have what we call ohmic conductors and we have non-ohmic conductor. What are the ohmic conductor? Any conductor that obey Ohm's law are called ohmic conductor. So the ohmic conductor, they are conductor. Ohmic conductor, they are what? They are conductors that obey Ohm's law. An example are of ohmic conductors. We have all metals. All what? All metals are ohmic what? Conductor. What are the example of metals? We have copper and we have tungsten. So all metals, they are what? They are ohmic what? Conductor. So any metals that is obey Ohm's law are called ohmic conductor. All metals are ohmic conductor, and the graph of ohmic conductor is always straight line, and it started from the what? Origin. And also what? The graph of what? Ohmic conductor is is always straight line that starts from the origin. Let us look at the graph of what? Ohmic conductor. If you are talking of ohmic conductor graph, their graph is always be in this form. This is what? Current in ampere, negative current in ampere. Sorry. So if you want to draw the graph of ohmic conductor, it's always a straight line and pass through the what? The origin. So this kind of graph is a graph of ohmic what? Conductor. But the next one is non-ohmic conductor. Non-ohmic conductor. So the non-ohmic conductor is the opposite of what? Ohmic conductor. They are substance which does not obey what? Ohm's law are called what? Non-ohmic what? Conductor. So the non-ohmic conductor, they are substance which does not obey Ohm's law. Examples are of non-ohmic conductor. We have junction diodes. Junction what? Diode, which is PN junction. We have neon gas. Neon what? Gas is also non-ohmic what? Conductor. Neon gas is also non-ohmic what? Conductor. We also have a diode valve. Diode what? Valve is also what? Non-ohmic conductor. We also have dilute A2SO4 is also non-ohmic what? Conductor. And in terms of the graph of non-ohmic conductor, they are not straight line, and they are not straight line. They may pass through the origin, at times not pass the origin. Difference between their graph is what? For ohmic conductor, we have a straight line curve. Non-ohmic conductor, their graph is not a straight line. Let's check the graph of non-ohmic conductor. So for the non-ohmic conductor graph, let me manage this side, this small side, yes. For the non-ohmic what? Conductor, yes. This is current, voltage, negative current, negative voltage, positive, and negative current. Good. See, if we have a curve in this what? In this, we have a curve in this form. Look at the curve. So this kind of graph is the graph of junction what? Diode. Junction what? Diode. So this curve is the graph of non-ohmic conductor. And we can also have this curve in this form. This is a curve like this. Yes now. So this curve is represents the graph of dilute A2SO4. And we can also have another graph of non-ohmic conductor, which is always be in this form. Right? And if you have your graph in this form, this is the graph of thermodynamic diodes. Thermo, thermo, what? Thermonic diodes. Diodes. So that is all about what? Ohm's law. So the Ohm's law is a law that shows the relationship between the voltage or potential difference and the current. So where the what? The resistor is remain what? Constant. And the Ohm's law can be grouped into two parts. We have ohmic conductors and non-ohmic what? non-ohmic conductor.